In the last video, we looked at how to use Matlab to implement some mathematical equations, and we looked at some of the intrinsic mathematical functions provided by Matlab. Right. So the example that we looked at was flow in a circular channel. This kind of problem. Right? And this time we're going to look at a slightly more complicated flow control. So there are two types of flow control. One is called branching, and the other one is called loops. We're going to look at branching first. Right? Branching is basically the kind of a construct that allows you to pick a particular path of execution based upon a certain condition. If the condition is evaluated to true, then you're going to take a certain path of execution, and then if it's evaluated to false, then you're going to take a different execution path, that kind of thing. So we're going to look at some examples. So the first example we're going to look at is a so-called it's a very simple code that allows us to convert point grades to letter grades. So usually if you take a course, right, you are going to accumulate a certain number of points during the semester, right? And then eventually those point grades can be converted into a letter grade, like A, B, C, D, that kind of thing. So how do we actually implement a Matlab function for us to do this kind of a conversion, right? Let me try to describe this problem in a more quantitative way. So point grades to letter grades, right? So the idea is actually quite straightforward. So we're gonna the total number of points for the entire semester is like 100. So we have 100 points in total, right? So if the student got more than 90 points, including 90 points, then the letter grade is going to be A, right? If the total number of points the student got was larger than or equal to 80 but less than 90, right? So including 80 but not including 90, then the letter grade is going to be B. Right? If it's between 70 and 80, then the letter grade is going to be C. If it's between 60 and 70, then the letter grade is going to be D. And if it's below 60, then the letter grade is going to be F. So the idea is kind of simple enough, I guess. But let's try to implement this kind of conversion in Matlab, right? So how do we actually write a branching kind of a flow control in Matlab? Let's create a script. Let's just call it letter 2. Oh no, point to letter, right? Point to letter dot m. Let's just create a ordinary script, right? It's not a rich script. So the first thing we're gonna do is to ask the user to actually so let's write a comment script for converting point grade to letter grade. So the first thing we're going to do is to ask the user of the script to enter the point grade. Please enter the point grade. So it has to be larger than 0, right? It must be larger than or equal to 0. So larger than or equal to 0 and smaller than or equal to 100, right? Let's just use P to indicate its point grade, right? That's our prompt. That's our prompt to the user. That's the point grade, right? It's probably better to just write point grade. And then eventually we're going to display a letter grade, right? Disp letter grade is letter grade. Right. For now, we don't have a letter grade yet, but from between this line and this line, we're going to write the logic for determining what's actually the letter grade. Right. So what's going to be the letter grade? What's going to be the letter grade? So how do we actually write this part of the code? Right. So we can start to we can write the code from top to bottom, for example, or from bottom to top. It doesn't really matter. Let's just write on from top to bottom. So we're gonna first write the condition for getting a letter grade of A. If the point grade is larger than or equal to 90, then the letter grade should be equal to A. It should be equal to A, right? So let's implement that part, right? So what's gonna be the condition for getting a letter grade of A? Right. The condition for getting a letter grade of A is what? Is point grade must be larger than or equal to 90, right? So in MATLAB, larger than or equal to is kind of like that, right? We looked at the equal to, right? Equal to is a comparison that to check if the left-hand side is identical to the right-hand side, has a value, right? Has a value that's identical on both sides, right? And then if you change it to larger than, then it's going to be larger than or equal to. So if the point grade is larger than, or if the point grade is equal to 90, then the letter grade should be A, right? So that's our condition. That's our condition, right? So in order to write a branching structure, we have to use the MATLAB keyword called if. So as soon as I type the if, it's gonna be displayed in blue, right? Which means that it's actually a MATLAB keyword. So if point grade larger than or equal to 90, right? And then if I put my cursor at the end of this line, this if statement, and press enter, you can sort of see the MATLAB editor automatically puts my cursor sort of at a position that's kind of indented with respect to if. And the indentation is supposed to be like 4 spaces. So 1, 2, 3, 4. That's exactly 4 spaces, right? So if every line that I'm starting to type now is going to be indented with respect to the beginning of the if statement by like 4 spaces, and that's kind of the default indentation in the MATLAB editor, right? So if point grade larger than or equal to 90, then letter grade is going to equal to A, right? If we put an A between a pair of single quotes, then that becomes a string, and we're assigning this string to letter grade, right? Use a semicolon to suppress the output, right? And then we press enter again. Again, by default, the editor is going to put the cursor at a position that's kind of indented with respect to the beginning of the if statement, right? So that's the condition for getting a letter grade of A, right? Then what's going to be the condition for getting a letter grade of B? The condition for getting a letter grade of B is what? Is larger than or equal to 80, but smaller than 90, right? But smaller than 90, right? So what's going to be the condition for getting a letter grade of B? What's going to be the condition? One condition is that it must be larger than or equal to 80, right? So it must be above 80, including 80, right? That's one of the conditions. But at the same time, it must be less than 90, right? So less than 90 is actually a condition that's just the opposite of the condition for getting a letter grade of A, right? For getting a letter grade of A requires the point grade to be larger than or equal to 90, right? And the opposite of that is smaller than 90, right? So part of the condition that B, for getting a B grade, is just the opposite of the getting an A grade, right? And MATLAB actually provides a construct for implementing exactly like that kind of thing. It's called else, right? Else. So as soon as you type the else, you can sort of see the MATLAB actually automatically puts the MATLAB editor automatically puts the else that we just typed to at the same kind of indentation as the if statement. So you're not indented with respect to the if statement anymore. Right? Else is actually at the same kind of column, at the same kind of indentation as if, which means that it's actually at the same level. It's actually at the same level, right? So else is also a MATLAB keyword, so you can sort of see it's actually in blue, right? So as soon as you type the else, MATLAB actually recognizes that this condition has been evaluated to false, right? So all the lines that you're going to write below this else statement is going to be for the condition that this statement is evaluated to false, right? So if this statement evaluates to true, then this line is going to be executed, and then the entire if structure is going to be so MATLAB is going to exit the entire if structure, right? But if this condition is going to be evaluated to false, which means point grade is smaller than 90, then MATLAB is going to look at all the else statements, right? But our condition is not just smaller than 90, right? For getting a letter grade of B, the condition is not just smaller than 90, right? Smaller than 90 can also be a D grade or F grade. If you get a point grade that's less than 60, then you are supposed to get an F instead of B, right? So in order to get a B, a second condition is what? A second condition is that the point grade must be larger than or equal to 80, right? So in MATLAB, how do you actually express that? So else is going to tell MATLAB that all the following statements is kind of a sort of for the condition that this condition is evaluated to false, right? But how do I actually express the additional condition that the point grade must be larger than or equal to 80, right? And in this case, we can write else if, right? Again, else if is also a MATLAB keyword. And then if we write else if instead of else, then we can sort of follow this keyword with another condition, which is point grade is smaller than, larger than, or equal to 80, right? So this else if, the condition that's gonna follow this else if, is gonna be evaluated when this condition is actually false, which means point grade is less than 90, right? And then if point grade is less than 90, then this condition is going to be evaluated by MATLAB. And MATLAB is going to see if is going to check if point grade is larger than or equal to 80. If this condition is evaluated to true, then the statement here that's going to be letter grade equals to B. This line of code is going to be executed, right? And then we can sort of keep writing the rest of the logic. We're going to repeat else if point grade larger than or equal to 70, right? That's sort of the next grade level, right? That's the next grade level. That's larger than or equal to 70. So letter grade is supposed to be C, right? So and then else if point grade larger than or equal to 60, then letter grade it's gonna equal to D, right? So by now we have finished A, B, C, and D, right? The code for all the four different grades, and then we have one more thing left. If the letter grade is actually below 60, then the letter grade is supposed to be F, right? If the point grade is less than 60. So how do we actually write this part of the code, right? And for this part of the code, all we have to check is if the letter grade is less than 60, right? If the point grade is less than 60, then it will always be F, right? It doesn't really matter if it's sort of above 50 or something. It doesn't really matter. As long as it's less than 60, it's always going to be a F. So we don't really have a second part of the condition, right? we have only one part. The condition is just if it's less than 60, then it's going to be an f, right? So we really don't need to come up with another conditional anymore, right? There's no second test for us to determine if the letter grade is going to be an f, right? So as soon as this condition is false, so point grade larger than or equal to 60 is evaluated to false, then the letter grade is always f, right? So in this case, we don't really need to actually add another conditional behind the else, right? So here we're just going to use else. There's no if anymore because we don't really need to check a second condition. So letter grade equals to f, right? And then for every if, elif, else construct, we must use an and to enclose all the codes. So every if statement must have an and to be paired with it. So this keyword cannot be sort of neglected. It must be there, right, in order for the syntax to be correct. And later when we sort of look at the loop construct, it also has a and statement to actually tell Matlab that my construct is kind of complete, right? And by now our code is finished, right? But let's give it a test run and see how if it's gonna give us the right result, right? Let's just click on run. So please enter the point grade. Let's give it like 85, 87 or something. So letter grade is B. Oh, I forgot to put a space here. 87. Right. That's supposed to be correct, right? And then if I give it like 57, that's F, right? Let's run it here. Let's try to check a few more parameters. That's a C, right? 99, right? A, right? So A, B, C, F, right? Do we have a D? Let's check a D, for example, 67. Right, that's a letter grade of D. So it is performing in the expected way, right? But now let's look at this particular piece of code. Right? Let's look at this particular piece of code. This part of the code, right? And try to understand what's going to happen. What's if we actually do not use the correct ordering for the different conditions, right? So all the conditions that's being sort of written here looks like they are kind of similar, right? But suppose I switch the order of these two conditions, is it still going to be performing in the correct way, right? Suppose do I have a redo, undo? Let's cut this piece of code. Control X to cut it, and then Control V to paste it, and then we switch the order of these two codes, these two conditionals, right? Is that still gonna give us the correct result, right? Is that still gonna give us the correct result, right? So let's give it a run. Let's give it a run and see if it's gonna work. So please enter point grades. Let's give it like 87. 87 is supposed to get a B, right? But let's see what's gonna happen. So letter grade is A, right? So it's actually assigning the incorrect letter grade. But why is that? Right? The problem is that the ordering here really matters to the output, right? So point grade is 87. So Matlab is gonna actually check each of the conditional from top to bottom. It's not gonna sort of to check the conditionals from in any other order. It's just gonna check the conditionals from top to bottom, right? As soon as it sees the conditional, as soon as one of those conditionals is evaluated to true, Matlab is gonna exit this if construct, right? So if the point grade is 87, then point grade larger than or equal to 80 is automatically evaluated to true, right? And then Matlab is going to execute this line, assign A to letter grade, right? And then Matlab is just going to exit this particular if construct and then go to this directly. It's not even going to look at. Any of the rest of the conditionals, right? So all those kind of conditionals are mutually exclusive, actually, right? As soon as MATLAB finds like one of them is true from top to bottom, as soon as MATLAB finds one of them is true, it's gonna execute the statement inside of that block, and then exit the if construct, right? So every time only one conditional among all those conditionals are gonna be evaluated to true, right? So the conditionals must, when you construct those conditionals, you must make sure that the logic is right. The logic is right. Right. But suppose so here the letter grade is incorrect, right? The letter grade is incorrect for 87. For 87 it's incorrect because it doesn't actually check this line of code. It doesn't check. As soon as this is evaluated true, it's gonna execute this line and then exit, comes to the end. So it's not gonna check the rest of the conditionals, right? But suppose the letter grade here is wrong, but maybe you think that it's just because this statement is wrong. When we switch to the conditionals, right? When we switch to the conditionals, the two conditionals here and here, right? We didn't actually switch to the letter grade, the assignment, right? So let's change that also. Right. And see if that's gonna make any difference, right? And then let's run it again. So now let's suppose still we type 87, right? This time it's supposed to give us B, right? Right. Letter grade is B, right? So the behavior is correct for 87, right? Now let's run it again. And then let's give it a 95. For 95, you are supposed to get a letter grade of A, right? But let's see what's going to be the output. The letter grade is still B, right? Because when MATLAB actually sees 95, so point grade is 95, right? 95 is larger than 80. So this condition is evaluated to true. And then this line is going to be executed, right? So letter grade is automatically assigned to A, to B. And then MATLAB is going to exit the if construct, right? So it's not going to even look at the second conditional, right? If MATLAB actually checks the second conditional, it will find that 95 is indeed larger than or equal to 90, right? And then the letter grade would be corrected to A instead of B, right? But MATLAB doesn't do that. So as soon as it finds that this first conditional is already evaluated true, it's going to ignore all the else if and also the else. It's going to ignore all the rest of the codes. And then directly comes to the end. Right. So how do we actually change this piece of code? If we want to just write this part of the code, if we want to write the code, this part of the code in this particular order, how do we actually make sure that the behavior is actually correct, right? How do we actually make sure that, right? So what's actually the correct condition for point grade, for letter grade to be B, right? So what I was saying is that for letter grade to be B, the correct condition has two parts. One is that it must be less than 90. And the other part is that the point grade has to be larger than or equal to 80, right? It's got two conditions, right? When this particular condition is inside of the else if, the first part of the condition is actually implied by the else, right? The else actually implies that point grade is smaller than 90 because when we actually put this condition on top and this condition as the second condition, right? The else automatically implies that the point grade is less than 90, right? So that condition is implied just because this point grade larger than or equal to 80 is the second one, right? It's the second one, and this one is the first condition, right? So if we want to write point grade larger than equal to 80 as the first condition, and then point grade larger than or equal to 90 as the second condition, then when we write the conditionals, we must make sure that both conditions are evaluated. So it's not just the larger than or equal to 80, right? We also have to make sure that point grade is smaller than 90, right? So we have two conditions. We have two conditions. And these two conditions are connected with this symbol. This symbol actually means a logical AND, right? So the entire thing is going to be true. So the entire thing, the entire expression that's in blue here, is going to be true only when both conditions are evaluated to true. Right? These two ampersands next to each other. Right? So now let's try to find out if the behavior is correct, right? So 95, point grade is 95. Now it's correct, A. It's giving you the correct result. Right. The reason is because now MATLAB still checks from top to bottom, right? But when the point grade is 95, yes, it is true that it's larger than or equal to 80, right? And is it going to be smaller than 90? No, 95 is not smaller than 90, right? If it's not smaller than 90, then the whole thing in the blue part, in the select part, is going to be false, right? So MATLAB will actually have to look at the second condition. It's going to have to look at the second condition, right? Because this one is actually evaluated false, so it must check all the else branches, right? And the next one it's going to check is this line, point grade larger than or equal to 90. And 95 is indeed larger than or equal to 90, right? So it has found that the second condition to be true. So it executes this part of the code, assign A to letter grade, and then it's going to exit without checking all the rest of the code. Without checking. It's not going to check if it's larger than 70, right? If it checks if it's larger than 70, then this condition is going to be evaluated true, right? It's going to be evaluated true, right? 95 is certainly larger than or equal to 70, right? So if it finds it to be true, then if it's going to evaluate this line, then you're going to get a letter grade of C, right? Even though you got a point grade of 95, that's still incorrect grade, right? The reason that the grade is correct is just because MATLAB doesn't actually check those conditions, those two conditions. As soon as it actually finds this condition to be true, it's going to exit. It's going to come to the end of this particular construct. Right. So, now let's try to encapsulate this part of the logic into a MATLAB function. Right. Let's create a new function. Right. The output args is going to be letter grade. And then the function name, let's just call it point grade 2 letter grade. And then the input argument is going to be point grade. Right. And then let's just write some symbol comment. Convert point grade to letter grade. Right. And then the input point grade 0 to 100, right? And then letter grade is supposed to be A, B, C, D, E, F, right? What we can do is just to cut this piece of code and then paste them into this part of the function, right? And then let's save it first. So one of the good habits when writing a function is to actually check if the input is within the specified range, right? So now let's look at what's going to be the logic for point grade. So if the point grade is less than 0, for example, it's a negative number, then it's not a valid point grade, right? And then we don't really need to actually check all the rest of the codes anymore. We don't really need to actually so MATLAB can just exit now. It doesn't really have to sort of execute the rest of the code, right? And if the point grade is larger than, or if the point grade is larger than 100 points, 100 points is like the maximum point, right? If the point grade is larger than 100 points, then it's also not a valid, it's an invalid input, right? So if, let's write a logic to check the input. So if point grade smaller than 0, it's a negative grade, right? Or the point grade is larger than 100, right? So we looked at this ampersand, these two ampersand next to each other. That's a logical AND. So the entire thing is going to be true only when both of them is true, right? Both of them is true. As long as one of them is false, then the entire thing is going to be evaluated to false, right? And if both of them are false, then the whole expression is also false, right? And these two vertical bars next to each other is a logical OR. So the entire expression is going to be evaluated true as long as one of those expressions is true, right? And if both of them are true, then it's also going to be evaluated true, right? As long as one of them is true, then the entire thing is going to be evaluated true. And if both of them are actually false, then it's going to be false also, right? So what's going to be the statement that we're going to execute inside of this if construct, right? If point grade is smaller than 0 or point grade is larger than 100, which means that the input is invalid, right? And at this point we can display an error message to the user, right? So the MATLAB function for displaying an error message is called error. Invalid point grade must be larger than or equal to 0 and smaller than or equal to 100, right? Let's display the error message. And then because we don't really have any kind of we don't really want to write any kind of a code for handling the else part, right? If the point grade is indeed valid, then all the rest of the codes are gonna handle that correct logic, right? So we don't really need to write an else to handle the correct logic. All the rest of the codes are gonna handle it. So we can just end the if construct right here, right? And this way we can sort of finish our function. And let's save it. And then now we can actually go back to the script and just call this function. Let's just do letter grade equals to point grade to letter grade, right? And then point grade as the input, right? And if we execute this particular script, it's gonna call that function, right? Now let's give it like a negative number, minus 60 or something, right? And see what it's gonna do, right? It's gonna report an error message, right? And invalid point grade must be larger than or equal to 0 and smaller than or equal to 100, right? And this error prompt, this kind of error information was encoded as the input to the MATLAB's intrinsic error function, right? And let's try to execute it again, but I give it like a 150. And again, it's gonna give us this particular error message, right? And this error message is something that we gave to the error function, right? And now if we actually run it with a grade that's like a 56 or something, then the letter grade is F. So the behavior is correct, right? 97. A. Sorry, 85. Then B, right? let's get a C. That's a C, right? And then if it is 68 or something, then it's a D, right? So now the behavior is what we are expecting. And that's our example for point grade to letter grade, right? This kind of conversion. And we looked at some of the basics about this kind of if branches, this kind of branching structure for flow control, right? And let's look at another example. Let's look at another example. Let's look at another example. And this example is again taken from the textbook. Right, that's our textbook, and it's example 4.1. It's called fatigue strength factors. Right, fatigue strength factors. It's a problem for computing a particular fatigue strength factor, and this particular fatigue strength factor actually depends upon three things, three factors. One is called the C load, and the other one is called C size, and then the other one is called C temp. Right, so the fatigue strength factor, that's called C, is a multiplication of C load with C size and C temp, right? But in order to actually determine C load, C size, and C temp, we need to actually check those conditions, right? So if it's a bending load, so this is some kind of fatigue strength factor for metal. Suppose you have a metal bar. It's a metal bar, right? And the load that you are applying on that metal bar is bending. It's a bending load. Then the correction factor for load is going to be 1. And if it's axial, it's kind of an axial load, right? Then the load factor is going to be 0.7, correction factor for load. And then the correction factor for size is going to depend upon the diameter of that metal bar. Suppose the metal bar has a circular cross section, right? And if the diameter is smaller than or equal to 8 millimeters, then the correction factor for size is going to be 1. And if it's between 8 and 250 millimeters, then the size is going to be, the correction factor is going to be this particular expression. And then also we have a temperature correction factor, and also depends upon the range of the temperature. Right. Again, let's sort of try to implement this particular. Let's try to solve this problem by first writing a Matlab script and then write a Matlab function. Right. But this time I will have to sort of look at the expression in order to actually complete the exercise. So let's put Matlab and the problem side to side. And resize the window. Okay, so let's try to edit a new script. Right. Fatigue strength factor. Let's just save it as fatigue. So again, we're going to ask the user for entering the load, and then the diameter, and also the temperature. Right. The load is going to be a string. It's going to be a string, right? And then the size is going to be a number, and then temperature is going to be a number, right? So let's call it load. But load is actually not a very good name. Let's change it. Let's change it to load. Right? In Matlab it might be okay, right? Because the load is not a Matlab keyword. Looks like it's not, right? Otherwise it's going to be blue, right? But nevertheless, let's change the spelling so that it doesn't actually have any kind of conflict with the other things. But anyway, that's load is going to equal to input, please enter the load type. Right. And then the size. If you type size, then that's going to be a Matlab function. It's not a good idea to actually use the name of a existing Matlab function to actually do the as a name, right? So let's just call it d because it's diameter. So please enter the diameter. Right. And then temperature. Let's call it what? Let's call it TMP input. Please enter temperature. Oh, I got a spelling error here. It's a semicolon. Right. So now we got all the inputs from the user. And now we have to implement our logic, right? So let's first check the load. If load, we compare it with bending. So if load equals to bending, then C load, let's use a capital C, right, to be consistent with more consistent with the mathematical symbol here. Even though load is used as a subscript, in Matlab we cannot actually do a subscript, so let's just use a capital C and a small case load, right? And then it's gonna equal to 1.0, right? And then else if load equals to not bending anymore, axle, and then C load is gonna equal to 0.7, right? And in fact, this table only gave us two situations. For any other kind of a loading type, we're gonna report error, right? The code is gonna should report error, right? So else means that both conditions has been evaluated to false. It's neither bending nor axle. So if this is the case, let's just report an error. No such loading type. And then we can sort of end the if block, right? And that's the logic for checking the load, basically. Right. And then we need to write the logic for checking the diameter, right? In any case, the diameter should be a number that's larger than 0, right? It cannot be sort of smaller than 0. If it's a negative number, then it must be something wrong. So if d is smaller than 0, then we're gonna report error, right? Error. Negative diameter. Not allowed. Else if. So if this condition is evaluated to false, which means that the diameter is larger than 0, right? And if that's the case, we're going to check the first condition first, right? If d is smaller than or equal to 8 millimeter, oh, probably it's a good idea to enter millimeter here, to tell the user it's a millimeter, right? So if d is smaller than or equal to 8 millimeter, then C size should be equal to 1, right? And then else if the diameter is so the mathematical condition here is like having some kind of conflict, is it? So if it's so the equal to 8 millimeter is like duplicated for both cases, right? So if d actually equals to 8 millimeter, which condition should you use, right? So the mathematics seems to be not exactly consistent. So else if d, we don't really need to write this part of the code, write this part of the condition, because the else actually implies that it's larger than 8 millimeter, right? So by using else if, we're actually assuming that d is already larger than 8 millimeter, right? So let's just we don't really have to write this part of the condition. All we have to check is that if it's smaller than 250 millimeter. smaller than or equal to 250, right? And then C size is going to equal to what? 1.189 multiply the diameter to the minus 0.097. So 1.189 multiply d to the power of minus 0.097. And then else, if we come to this particular else part, which means what? Which means d is actually larger than 250, right? And in this case, we are also going to report an error. Diameter larger than 250 millimeter. Right. And then we can just end this block for checking the diameter. And then the last logic is temperature, right? Temperature can certainly be a negative number, right? So we don't really have to sort of check if the temperature is smaller than 0 or not, right? So we only have like a one condition. If it's smaller than 450 Celsius, then it's gonna be 1, right? C temp is gonna be 1. Otherwise, it's gonna be this particular complicated formula, right? Let's tell the user what's gonna be the Celsius. Right, what's going to be the unit? So if temp is smaller than or equal to 450, right? And then C temp is going to equal to 1. Right? And then all we have to do is to write else, right? If this condition is false, then the temperature must be larger than or equal to 450, right? So we don't really need to write the second condition explicitly because the else actually implies that, right? So in this case, C temp should equal to 1 subtract 0.0032 times so it's T subtract 840 temp subtract 840, right? It's not T because we are not using T here. So that's the end of the and then the entire correction factor, let's just call it a C fatigue, is going to equal to C load multiply with C size multiply with C temp. And then we can just do this fatigue correction factor. Fatigue strength factor. And then num to strc fatigue, right? And that's our entire string, right? And now our code is completed, right? Let's give it a run and see what's going to happen. And loading type, let's give it like a let's give it like bending. Yeah. Oh, load type. Oh, bending. Looks like you have to sort of, because it's expecting a string, so you have to give it a string. If we just type bending without the single pair of quote, it's gonna expect it's not gonna be treated as a string, so it's giving us this error message. Right? And then diameter, let's give it like say 10 or something, right? 10 millimeter. And then temperature Celsius, let's give it like 800 or something, right? And then it's gonna give us a fatigue strength factor 1.0727, right? But the user of your program probably doesn't know that it's expecting a single quote, right? So how do we actually automatically ask Matlab to treat the input as a string, right? So if we check the manual page for the input function, help input, so it should give us some kind of indication. So if you sort of look at the second input, right? So the first input to the input function is a kind of a prompt, right? It's going to be displayed on the screen and tell the user what's expected, right? And the second input, this s inside of a period of a single quote, is actually telling Matlab that you should treat the input, whatever the input the user has typed, as a string, right? Even if the user has typed in a number, you should still treat that number as a string, right? So, right, it's telling you that if you use this kind of a syntax, returns the entered text as a Matlab string without evaluating the expressions, right? So what we might want to do is to actually change this line of code, change the first input, and then give it a second input to s, right? So now if we run it again, please enter the, let's get an exo, right? And then it's not giving me an error message, right? Even without the single quote, to enclose it. And then the diameter, let's give like the 5 or something, right? And then temperature cells 250 maybe. Matrix dimensions must agree. So it looks like it's giving me doesn't allow me to actually do a comparison inside of my script. So load has an content of axle, right? And then if I do comparison, load compare with bending, so it's giving me a matrix dimensions must agree. It's giving me some kind of thing that's kind of unexpected. So why is that? So size of load, it's going to be 1 row 5 columns, which means we have 1, 2, 3, 4, 5 characters in it. And then size of bending is definitely not 5, right? It's 1 row 7 characters. So it's not allowing me to compare strings with different characters, different number of characters. Right? But that was not a problem when we actually gave the input. So if I do load equals to axle, right? Oh, bending. In the previous example, we're using bending as an example, right? So if I do load compare with bending, then it's telling me matrix dimensions must agree, right? String comparison. So it's giving me a logical 0. So here I'm using the strcmp function instead of using this equal to comparison, right? And then if I compare it with axle, it's giving me a logical 1. So it looks like you cannot just use a double equal to compare strings. In Matlab, you probably want to use strcmp. Again, it's a Matlab intrinsic function, right? You probably haven't actually seen it before, but we can find it out how to use this particular function, strcmp. And then compare strings or character vectors, right? It's expecting 2 strings as input. Compares S1 and S2, and then returns logical 1 if they are identical, and return logical 0 otherwise. Right. So let's change this double equal to strcmp to compare strings. Right. Yeah, I think that's gonna fix it, right? And the load type, we call it axle, right? Diameter, let's give like 5 meters, it's 250 degrees, right? And then fatigue factor is 0.7, right? So now it's not giving us any kind of error message, right? The only thing that's not expected was that Matlab doesn't allow us to actually compare strings with double equal, right? You have to call strcmp, this intrinsic function, in order to compare two strings. Right? And again, we can actually try to encapsulate the entire logic into a function, right? Now let's try to create a new function. And let's call the output argument is just the C fatigue, right? And then the input arguments is going to be the load type, and then the diameter, and then what else? It's going to be the temperature, right? TMP, right? So and then let's call the function fatigue strength. What's actually the name of it? It's called fatigue strength factor. Right. And then I will just neglect the comment part, right? But in practice, you should do that. But here, for just demonstration purposes, I'll just neglect that particular step, right? Let's just cut the code, right? And then paste it over here, right? And then let's just save it. And then inside this fatigue.m, we can just call that function, right? So C fatigue is going to equal to fatigue strength factor, and then load D, and then temp as the inputs. And then if we run it, present the load type, let's call it bending, right? And then in diameter, like that's 20, temperature 70, and then it's giving us the fatigue strength factor as a output. So in these two examples, we have looked at how to use Matlab's if-elseif-else-end construct, right? And how to actually use this kind of branching structure to build into our own logic, right? And we looked at how important it is to actually put the conditionals in the correct order. That's kind of the branching structure. Matlab has other branching structures, for example, switch, right? Switch. But instead of talking about the switch statement, we're going to talk about the loops in the next video. How do we actually write loops in Matlab? And then we can sort of move on to slightly more complicated examples.